Okay, so today we want to focus on probabilities, specifically on the conditional probabilities, and we've been alluding to it and doing a little bit of it as we have been starting this unit. So let's dive into this first section on adding and subtracting probabilities. So you can see it says, an online bookstore offers a large selection of books. Some of the books are fiction and some are not. Also, some of the books are available as e-books and some are not, right? Electronic books. Let F be the set of books that are works of fiction and E be the set of books that are available as e-books. Then it says, suppose that 62% of the books are works of fiction, 40% are available as e-books, and 14% are available as e-books, but not works of fiction. A book will be selected at random. So we're going to actually put this together both as a Venn diagram and as a hypothetical 1,000 two-way table. And so let's go through first and do the Venn diagram. This will be a good review. And so you can see here, the first piece of information is that 62, what I wanted a highlighter. There we are. 62% of the books are fiction. So that's all of the fiction books. So I'm going to write here, I'm going to write it as a decimal, 0.62, and connect that here, because it's the whole circle. Which, by the way, what the square represents 100%. Isn't that 1.00? The next piece of information that they're going to give me here is that 40% of the books are available as ebooks. Okay, well that's the other entire circle. So this is going to be 0.47, and that's this entire one right here. And then there's one more piece of information that they give me, and it's that 14% of the books are available as ebooks, but not works of fiction. So I've got to figure out, well, where is that in the graph? And in the graph, that's going to be most of the circle E, right? But they're not works of fiction, so it's just not where it intersects with the F circle, right? Books of fiction. So this is 14%, which is 0.14. So if I want to complete the Venn diagram now based off that information, I can figure out, the first thing that's going to be easiest to figure out is going to be, right, this middle section, because we have the whole circle of E and we have the partial, so we can subtract those. So that would be 0.47 subtract 0.14, and that gives me 0.33. So this section here is 0.33. Now I can figure out we have all of F, right? That's the 0.62. So, and we have this portion of F, so we can figure out what the remainder of that circle is. So by subtracting the entirety, so I'm going to take that 0.62 and then subtract that 0.33. So I'm going to have to borrow here, right? It gives me 929, 0.29. Okay, and now I just need to calculate what is outside of the two circles, right? That would be the books that are not available as ebooks and are not works of fiction, right? So in order to do that, we're going to take our 100%, right, the 1, and we're going to subtract the 0.29, right, we're going to subtract these numbers here. Subtract the 0.33 and subtract the 0.14. Okay, and when you subtract those numbers, you get 0.24. Would it be faster? Could I just subtract these up here and do 1 minus the 0.62 minus the 0.47? Could I just subtract those? Can I? So, and the answer is no, right? Because the 0.62 contains this 0.33, and that 0.47 also contains it, right? So you'd actually be subtracting that 0.33 twice. Does that make sense? When you subtract the 0.62, you're subtracting this section once because it's a part of it. And then when you subtract the 0.47, you're subtracting that section again. Is that clear? Okay, it's an important part of understanding like probability, okay? Okay, can we move on? So then you can see here in problem 2, right? Use the Venn diagram, find the following probabilities. So this time we're going to be looking for the book is a work of fiction and available as an ebook. So what part of the graph would represent work of fiction, right? And available as an ebook? What part of the Venn diagram is that, you guys? The middle, where the two circles intersect, right? So it's going to be this section right here. All those are, anything in that section is going to be in the circle work of fiction and in the circle ebook. So the answer to that one is going to be 0.33. Okay, how about that the book is neither a work of fiction nor available as an ebook? Well, where is that going to be in the graph? What was that? Outside of the two circles. That's going to be what's out here, and we had figured that out already. It was the 0.24. So I just have to, right? So once we've filled in the diagram, those two questions are just how do you read the diagram? Okay, how are we doing with that? We cool? Can I bump this up now? Okay, then in 3 it says, let's return the information given at the beginning of exercise 1. 62% of the books are works of fiction, 47% are available as ebooks, 14% are available as ebooks but not works of fiction. And it says, use the information to fill in the hypothetical 1,000 table below, right? Two-way table. So let's get going here. So let's start with this 62% of the books are fiction. So of my cells, right, 1, 2, 3, 4, 5, 6, 7, 8, 9 is already filled in with 1,000. Which of those 8 cells is going to represent all of the books that are works of fiction? Okay, do you guys agree that it's going to be 7? Yeah, it's totally going to be 7. So I'm going to take this here, right? I'm going to highlight it. And I'm going to put in the 62, right? If I change that to a percent, it's 0.62, so that's going to be 620 here, isn't it? Oh, I can already fill in another cell. Can't I fill in this cell right now? What's this cell going to be, you guys? Okay, 380, is that right? Because don't they have to add, right? These two cells have to add to be equal to 1,000, don't they? So we can get the 380 by taking the 1,000 and subtracting 620 from it. Let's get the next piece of information. So the next piece of information is that 40% of the books are ebooks. Okay, so where on the chart are the ebooks, right? 1, 2, 3, 4, 5, 6. I don't have to put 7, 8, 9 because they're already filled in. So which cell is going to represent all the ebooks? Okay, do we all agree that it's 3? Yeah, so what we're going to do is I'm going to take this right here, and that going to represent all of the ebooks. So that 0.47 becomes 470. Are we okay with that? Okay, so the nice thing is I can calculate this cell now, right? It's cell 6. And because these, right, two have to add up to the 1,000, don't they? So, or I could subtract from 1,470. So 1,000 minus 470 is 530. Are we okay with that? Now notice if that's all they did is gave us that information, it doesn't give us enough to fill in the table. We actually need one more piece of information, any of those 4 cells, and that would work. And so you can see here, they give us one more piece of information. It's that 14% available as ebooks, but not as works of fiction, right? And so I have to figure out what cell that is. This is 1, 2, 3 is filled in, 4, and 5. So all the other cells are filled in. So of those 4 cells, 1, 2, and 4, 5, which one of those represents ebook but not work of fiction? Okay, do we all agree that it's 2? Okay, so I'm going to highlight 2 right here. And we know that that's 14% is 0.14. And then writing that as, or multiplying that by 1,000 will give me 140. Okay, and then the nice thing is I can start figuring out, right? I know that these have to add to 470, right? This plus this equals. So if I take 140 and subtract it from 470, is that 330? Okay, I know that these have to add up to give me 620, right? 330 plus something has to be equal to 620. So 620 minus 330, I'll just tell you, is 290. And then to get that last cell, we can either figure out what adds this way, right? Adding those. Or I could figure out what adds to 290 to give me the 530. Got it? So I can do the arithmetic easier this way because of the numbers, right? So what do I add to 140? Well, I would take 380, subtract 140, and when I do that, I get 240. Okay, and they just want to see that you could also fill it in with probabilities, and that also works nice. Notice that all you have to do to each one of those is just move the decimal, divide by 1,000, right? So you would move the decimal 3 times, right? 1, 2, 3. So, whoops, let's do it in gray. So that would be 0.33. Do you see that? So the next one to the right, isn't that just going to be 0.14? And the next one to the right, 0.47. And then I'm going to take the 290, that becomes 0.29. 240 becomes 0.24. 530 becomes 0.53. 620 is 0.62. 380 is 0.38. And then obviously 1,000 divided by 1,000 is 1, and I'll put 0.00 since everything is to 2 decimal places. Okay. Do you get how to fill in the two-way table? Okay, from a Venn diagram. You notice you could even do it from the Venn diagram or from the words. Okay. So it was a good review of what we have been doing, right? So let's dive into the next one. Okay, Rufus King High School. Students at Rufus King High School were discussing some of the challenges of finding space for athletic teams to practice after school. Part of the problem, according to Kristen, is that female students are more likely to be involved in an after-school athletics program than male students. However, the athletic director assigns the available facilities as if male students are more likely to be involved. Before suggesting changes to the assignments, the students decide to investigate, right? Just because you make a statement doesn't mean it's true, right? But just because you make a statement doesn't mean it's false either, right? So it's like, well, let's see what the truth is to that statement. Suppose the following information is known about Rufus King High School. 40% of students involved in one or more of the after-school athletic programs offered at the school. 40% of the students are involved. It's also known that 58% of the school's students are female. The students decide to construct a hypothetical 1,000 two-way table, table 1, to organize the data. So you can see I have table 1 here. And if we look at it, right, we have a column for yes, that they participate in an after-school program, and no, they do not, right? And then we also have it broken down by gender, female and not female, right, male. And then total, you can see there's columns for totals. So let's take a look here at organizing data. It says, there we are. It says, what cells in table 1 can be filled in based on the information given about the student population? Place these values in the appropriate cells of the table based on this information. Well, I'm just going to work on this top one here for a second, but we're obviously the other one down below we're going to fill in. And so the first piece of information that I have in the words up above is right here. 40% of students are involved in one or more of the after-school programs offered at the school. Okay, so what cell is going to represent that? Is it broken down by gender? Is what I have highlighted in orange broken down by gender? Is it 40% of males, 40% of females? Nope, it's 40% of students. So it's not going to go in a specific inside cell, right? It's going to be in the totals, right? We're just looking at students, right? And so then it's involved in an athletic program. So which cell is it? Yeah, 7. Okay, so cell 7. And just for the sake of the discussion, I'll write the 40% here, but we're going to work on that down below. Okay, and then they actually give you one other piece of information here, only 2 pieces of information. It's also known that 58% of the school's students are female. So notice again, we're just looking at all of the students, the entire population. 58% of them are female. So what cell will that be? Good job. It is cell 3. So I'll write it right here. This is 58%. Okay, and then just as a quick note, right, it's a 1,000 hypothetical 1,000 two-way table. right? And so we do know also from this information, cell 9. Right, which is going to be 1,000, but we know it's 100% also. So I'll say that, right, or 1,000. Okay, are we okay with that? So in what cells in table 1? Okay, well, we said we can look and see. We know cell 3, don't we? Here, I'm going to bump this down. Right, cell 3, this is 58% of the school population is female. We know cell 7, which is 40% of students involved in after-school program. Okay, and then we also know cell 9, which would be I'll say it's a 1,000 two-way table. But let's put parentheses here, 100%, just to keep the idea of percents going down. So which cells are not filled in, and why are you not able to fill them in? Well, I think we can already see, right? Okay, so can't we, it says which cells are not available to fill in, and why are you not able to fill them in? So which cells can we still fill in? Which one? Good. 8 and 6, or 6 and 8, right? Because, right, we know that, right, these have to add to be 100, right? And we know that these have to add to be 100. So we could calculate 8 and 6. So what cells can we not calculate? Yep. So it's cells 1, 2, 4, and 5. So why are we not able to fill them in? We need one of these cells to find the other 3. Okay, so I'm going to come down here. And it's going to ask us, it's going to give us one more piece of information about the athletic director. Indicated that 23.2% of the students at Rufus King High School are female and participate in an after-school program. Based on the information, complete the table below. So let's go ahead and fill in first what we did know from up above, and then start filling in things. So if you remember correctly, if you look back, this cell right here, right, that was the green cell up above, and you can see that's 58%. Now remember, this is going to be a 1,000 two-way table, and so I'm just going to need to multiply 0.58 by 1,000 and get 580. Are we okay with that? Notice too, I'll do cell 9 as long as I'm right here, right? That cell 9, that's this one. and we know that's going to be 1,000. So right away, I can fill in the cell between them, right? 1,000 minus 580 is 420. This is the last cell that they gave us in the original problem, which was 40%. And if I want to write that out of 1,000, 40% of 1,000, right, that's 400. Oh, and now I can find the cell that falls between the 400 and the 1,000. And so notice here, 1,000 minus 400, isn't that 600? So we said we could fill in all those cells and that we needed one more piece of information, which they gave us this time. The athletic director indicated that 23% of the students at Rufus King High School are female and participate in an after-school athletics program. So it's got to be in the female row, and it has to be in the yes column, and so that's going to be this column right here, isn't it? Or this cell 1. So 23, this is 0.232, isn't it? And multiplying that by 1,000 is 232. So I can see, okay, what adds to 232, right? To get the 400, I'll just tell you that is 168. Okay, and then I can go across here, right? What do I add to 232, right? What adds to 232 that equals 580? I'll tell you that's 348. And then to get that remaining cell, I can either do it by the row or the column. I'll do it by the column. What do I add to 340 to get the 600? And that's going to be 252. Okay. Any questions on how I constructed that problem? That two-way table, are we okay with that? Okay, then it says considers cells 1, 2, 4, and 5 of table 1. So cells, pardon me, cells 1, 2, 4, and 5, that's these cells right here. It says identify which of these cells represents students who are female or who participate in an after-school program. Okay, so we're just identifying which cells. What cells represent the students that are female? Knowing that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So just of these ones, right? Which ones of those represent cells that represent females? It's 1 and 2, right? Do we all see it? Okay, and then which cells represent who participate in after-school programs? What cells are those? Well, remember this is 1, 2, 3, 1, 2, 3, nah, sorry. 1, 2, this is 3, 4, 5, 6, right? I don't do 7, 8, 9. So we just need to look at 1, 2, 4, and 5. Which of those cells participate in an after-school program? 1 and 4, good job. So this would be, if we're saying or, right, because it has the word or, so it would be cells 1, 2, and 4, right? It's 1 and 2 and 1 and 4, but we don't have to repeat the 1. So that's going to be the answer there. All right, and then what cells of the two-way table represent students who are female and do not participate in an after-school program? So again, right, we're going to look at the difference with the word and this time. So female, what cells represent female of the cells, right? This is 1, 2, 3, 4, 5, right? It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So what cells represent students who are female? 1, 2, and 3? Yeah, they didn't limit the question before limited us just to 1, 2, 4, and 5. This time it didn't limit us, so it's going to be 1, 2, and 3. And then do not participate in an after-school athletics program. Which cells are those, right? So let me go here. 1, 2, 3, 4, 5, 6, right? 7, 8, 9. I should put all of them in. So they didn't limit us this time. So participate in an after-school program are which cells? Or do not participate. Sorry, do not participate. 2, 5, and 8. Do you all agree? So 2, 5, and 8. Okay, now notice, this time it's the word, this was the word or here, this is the word and. So when you and those, you're looking for the overlap. So you have 1, 2, and 3, and you have 2, 5, and 8. And so what cell are we talking about? Just cell 2. Bless you. Okay, can I bump this up? Yeah? Okay, so let's take a look here. Conditional probability. Another type of probability is called conditional probability. Pulling apart the two-way table helps us define a conditional probability. So basically what a conditional probability does to a two-way table is that it focuses us just on a row or just on a column. Okay, you just have to read the problem very carefully. So notice here they've taken out the row that contains female, and it's identical, isn't it, to the row that we had up here, right? So this row here, right, is what they have brought down here. Do you all understand that? So let's come down here and take a look. It says, suppose, I gotta make that a little bigger. Suppose that a randomly selected student is female. Now, see here, suppose that a randomly selected student is female. This is what's giving us the idea that we are going to only focus on this row. I call that the given. What is the probability that the selected student participates in an after-school program? This probability is an example of what is called a conditional probability. This probability is calculated as the number of students who are female and participated in an after-school athletics program, or the students in cell 1, divided by the total number of female students. Notice not the total number of students because it was given that it was a female, so we are going to pull from just this row, or the students in cell 3. When taking conditional probability from a two-way table, the denominator will generally be a row total or a column total. The notation for a conditional probability is B, then you have that straight line A, right? And that straight line that is right here, right, means given. So if I were to write it, usually you write it as P, right, of B, that line, and then A. And so we read this as the probability of B occurring given A happened. Okay, so let's come down here and take a look. It says the following are examples of conditional probabilities. Answer each question utilizing the appropriate notation. So it says here, what is the probability, right, we're doing A, what is the probability of a randomly selected female participates in an after-school program? Well, okay, so that a randomly selected female, okay, this is a given, right? So from the females, right, we're going to look and see what's the probability that they participate in an after-school athletics program. Got it? So let me first write out over here. I'm going to go way off to the left edge, and I'm going to say, okay, what's the probability, right, that they are in the after-school program? I'm just going to say in program, given that they were female. So let's come up here. And just look at this table, right? So how many of those females participate in an after-school program? Yeah, it's the 232 right here. So I'm going to bring that down here as the numerator, right? So 232 divided by, and then what is the total number of females, not students, but females? That's the 580 here. That's going to be your denominator. Can I just tell you what that's going to be? We'll use a calculator to calculate that. And that's going to be 0.4. Usually I'll write that one more decimal place just because, right, 40%. It's interesting that the author of this curriculum chooses to leave it as a decimal when our brains, like, I don't know about you guys, but the percent makes more sense to me, right? So, but we'll just make sure that we know both. Okay, how are we doing? Okay, so I'm starting to struggle because I need that table to be able to complete the rest of this. So let me do this. I'm going to put the table down here really quick, just copy it. Doesn't have to be perfect. I do need to answer C, and I am going to add a D because I feel like we need a D. So I'm just reduplicating that chart on the previous page. So we just have it here to reference. Okay, so I'm going to do F for female, M for male, total. Can I write yes for in a program, no for not in a program, and total just for the sake of this problem? And the numbers 232 going down 168, 400. In the no column, it's 348, 252, and 600. And in this last total column, 580, 420, and 1,000. Okay, so up here, right? So for A, we did that. We were just focused on this column right here, weren't we? Are you okay with that? So let's take a look at B. Okay. B says, what is the probability that a randomly selected male participates in an after-school program? Okay, so this time, right, we have the randomly selected male. That's going to be our given in this problem. Participates in an after-school athletics program. Okay, so this time, I'm going to do it in green. So we have the probability, right, that they are, I'll say, in program, given that they're male. So it's similar to the last one, but we're focused on, now, right, the given is male, so that means I'm going to focus on the male row. So that's this one right here. So I'm not looking at the whole table. It has a given, so I'm just focused on a specific part of the chart. So how many of these males are in an after-school program? That would be a yes, right? In a program. So how many males are in an after-school program looking at just the green row? 168, good. Okay, and then what's our total, given that it's a male? So you're only looking at the male row. What's the total? 420. I divide those, I get 0.4. I'll do 0 here, which is 40%. Ugh, there we go. Let's take a look at question C. Oh, I didn't say or 40%. So or 40%. Okay, so question C says a student is selected at random. What is the probability this student participates in an after-school program? Is there a given on this one? I heard someone say no. Notice this. Technically, there is a given, right? There's always a given. But the reason you said no is because there's nothing that directs our eyes to a row or a column, okay? And so I would say, yeah, you're right. There is no given. But the reality is that the student is selected at random is the given, right? But this is communicating here. It's communicating all students. So we're looking at the whole chart. So if we're looking for the probability that they are in a program, how many students are involved in a program? Isn't it the 400 divided by how many students total? 1,000, which is 0. That's 40. Okay, or 40%. Okay, they don't ask the question. Does it appear that it's unfair that more females are participating than males? of the females, we know 40% of them participate in a program. Of the males, we know that 40% of them participate in a program. Of all the students, we know that 40% participate in a program. So does it look like one gender is given preferential treatment? No, doesn't look like it, right? Based on the information, okay? So I want to do one more here. I want to add a problem, D. So let's come over here, and I'll say, what is the probability that a student who participates in an after-school program is female? Okay, is there a given on this one where we're going to focus on not the whole chart, but on a specific row or column? Is there? Isn't it this right here? A student who participates in an after-school program? Isn't this the given? Do you agree based on the wording? Okay, I'm going to do this one here in pink, right? We're looking to see if they are female. So the probability that you have a female, given that they're in a program, after-school program. So let me get over here and look at our chart. So if it's given that they're in an after-school program, then aren't we going to be looking just at this column here this time? Do you see that? So how many in that column are females? 232, right? Out of how many are in the program? 400. So when I calculate this, this is going to be 0.58. Okay, or 58%, right? Okay, are we good with that? Let's just do one more, a problem. Anyone still copying that down? Okay. Guided practice. So this is technically one that you guys should do on your own. We'll just kind of do it together here. 200 patients who had either hip surgery or knee surgery were asked whether they were satisfied or dissatisfied regarding the results of their surgery. Among the patients, 105 had hip surgery, 160 reported being satisfied with the results, 25 had knee surgery but were not satisfied. Use the information to fill in the Venn diagram and or table below, then answer the questions that follow. Be sure to utilize the appropriate notation in your answer. For the Venn diagram, the circles will represent hip surgery and satisfied. Okay, so let's put together our two-way table here. So we have our first piece of information, 200 patients had either hip surgery or knee surgery, right? And we're asked whether they were satisfied or dissatisfied with their surgery. So notice here, right, it's either hip surgery or knee surgery. So I'm going to put hip surgery here. Yeah. and then knee surgery here. And I'm going to put total here. And they did tell me that it was 200, so I can write the 200 down here. Are we okay with that? The next piece of information is 105 had hip surgery. Well, that's going to be this right down here, isn't it? 105. Well, we know right away how many had knee surgery because they have to add to 200. Isn't that going to be 95 here? Oh, I didn't fill in my other column. Isn't it going to be satisfied and not satisfied? In total. Okay, the next piece of information follows directly after the 105 hip surgeries. 160 reported being satisfied with the results. Okay, well, that's total satisfaction, so that's going to be over here. That's 160, which means 40 were not satisfied, right? Because they have to add to 200. Then they give us one more piece of information. And that piece of information is 25 had knee surgery but were not satisfied. So in the knee surgery and the not satisfied, that's going to be this cell right here. I'm shading in light blue. And that one was 25. So of the not satisfied, there were a total of 40, right? So what plus 25 equals 40? Well, 40 minus 25 gives me 15. And then I can add going down to find the remaining, right? So what plus 115 equals 105? Isn't that 90? So, and then 90 plus what gives me 160? That's going to be 70. Are you guys okay with that? If I wanted to fill in my Venn diagram, right, it's going to be 200 total. We know 105 had hip surgery. So that's going to be, oh, I've got to label my circles, 1H, 1S, right? Had hip surgery and we're satisfied. So 105 were the hip surgery. The 160 being reported satisfied with the results. That's going to be here. 25 had knee surgery and were not satisfied. So knee surgery is outside of the H circle, not satisfied is outside of the S circle. So for both of them, that means the 25 is going to go here. Now we can actually pull the rest of the information from the chart. Since we have it, we know that this middle section is hip and satisfied. Hip and satisfied, that's the 90. So that's going to go here. Hip and not satisfied, that's the 15. So it's going to go in this circle there. And then being satisfied but not hip, which would be knee, satisfied and knee would be 70. So that's right here. And that would be filling in the tables. Now, could I also do percents? Yeah. If a person with knee surgery is selected at random, what's the probability the person what's the probability the person reports being satisfied? Okay, is there a given on this one? What's the given? Person with knee surgery, right? Okay, so we are looking for the probability that they were satisfied, right? Given that they had knee surgery. Okay, so we know that they had knee surgery, so we're only focused on this column. If they were satisfied, isn't that the 70 over the 95 total? Are we okay with that? And when you divide those, you get 0.737 or 73.7%. How about B? If a person is dissatisfied, is selected at random, what is the probability the person had hip surgery? So is there a given on this one? Isn't it dissatisfied person? So this is the probability, right, that they had hip surgery given they were dissatisfied. Okay, so now we're going to be looking at if they were dissatisfied, that's not satisfied. That's limiting us to this row. So of that row, how many had hip surgery? 15 out of how many total? 40. And 15 divided by 40, I will tell you, is approximately 0.375. So 37.5%. Okay, and then our last one, if a patient is selected at random, right? Is there a given on this one? Right? Is there something that's going to cause us to focus on just a specific row or column of the chart? So that means that we're going to focus on if a satisfied person, not satisfied person, right? Or knee surgery or hip surgery. Do we have any of that in this little statement I've highlighted? And the answer is no, so it's a whole chart, right? So now we're going to do whole chart and we're going to find what's the probability that this person had hip surgery and was satisfied. So we're looking for probability, hip surgery, and satisfied. Okay, so how many people had hip surgery and were satisfied? Yeah, it's just the 90 that's right here. We're going to bring that down. How many total are there? 200. So that's going to be 0.45. That's 45%, isn't it? Okay, you can see the lesson summary there. You guys can take a look at that. And that will wrap up the lesson.